Hello guys, so let's discuss about the topic Chatelier principle. It is the topic of chemical kinetics. So first let's discuss why we will need to discuss about this topic. So as you see, Chatelier principle to predict the changes of effect in conditions in chemical equation. Okay, to find most profitable combination of reactant and conditions. So let's discuss what is chemical kinetics. So let me write it first. So what is the Chatelier principle? It explains how the reaction changes when their changes are made in pressure, temperature and concentration and addition of inert gases at the equilibrium. So it basically tells how the reaction responds to it. So let's understand this with an analogy. Okay, so let me draw a diagram first. As you see, there is a hollow sphere and there is a ball at the bottom of the sphere. So when we will try to move the ball to the upwards left or to the upwards right, it tends to move to its initial exit. It resists. It tries to undo the changes. So that is what Chatellier's principle is. The equilibrium will try to undo the changes what we made at the equilibrium. So there are various factors which change the conditions. So let's discuss about the factors. So okay, factors affecting equilibrium. So let me write. So basically, when we will try to change the conditions, so our reaction will react the equilibrium. The equilibrium will try to undo the changes. So how it will undo the changes? It will undo the changes by shifting in either forward direction or in backward directions. So here are some factors which affect the equation. So first one is pressure, second one is temperature, third one is concentration, or we can say number of moles, and the fourth one is addition of inert gases. So these are the factors affecting. Let's discuss about them in brief. So first, let me write about change in concentration. So let's take an example. So as we can see that Chatellier's principle works on reversible reaction. So here we have taken the formation of ammonia from N2 plus 3H2, which gives 2 moles of 2NH3. Let's suppose we decrease the concentration of N2 here. So let's decrease. So our change is the decrease in N2. So when we will try to undo the change, which the equilibrium will try to undo the change. So the equilibrium will try to undo this change. We have decreased the concentration of N2, so equilibrium will try to increase the concentration of N2. So the reaction will move backwards. Okay, let's see if we try to increase the concentration of H2. So this is a change made. So when the equilibrium will try to undo the change, as we have increased the concentration of H2 here, so equilibrium will try to reduce the concentration of H2. Okay, so it will try to reduce the concentration of H2. So what will happen? So it will move in forward direction, so that more and more hydrogen will be used. Okay, so more and more hydrogen can be utilized. So it will move in forward direction. So, but as you can see, we can use these from the following examples. We can see how we can increase the yield, or we can say the product. Okay, so that is also one of the principle of Lee Chatelier. We can increase the amount of product, which can be helpful in various industrial uses. That is one of the industrial application of Lee Chatelier's principle. So let's discuss. So there are two. We can say there are two steps: addition of reactants. Two methods: reactants and removal of product. So as you can see, when we will remove the product, as that means we can reduce the concentration of product. So it will try to undo the change. The equilibrium will try to undo the change. So it will try to increase the concentration of NH3 to its initial concentration. So it wants to increase the concentration of NH3. So the reaction will move in forward direction, which will result in the increase of NH3. And same goes with addition of reactants. So let's discuss about the second factor, which is change in pressure. So let me rub it. So let me write it. So what will happen with change in pressure? Let's discuss it. So whenever there will be a change in pressure, whenever the pressure is increased, the reaction will move in that direction where the number of moles are less. We will discuss about the reason behind it, but let's talk about the change. Okay, we will discuss the reason behind it further in the video. So let's discuss what will happen if we increase the pressure. So whenever the pressure increases, the equilibrium will see where the reaction will move through. If the number of moles at the reactant side is more, then it will move towards the product side. If the number of moles at the product side is more, then it will move towards the reactant side. Okay, and vice versa if we decrease the pressure, it will move in the direction where the number of moles are more. So as you can see in this reaction, whenever we will increase the pressure, and here you can see there are 1 mole of N2O4 and there are 2 moles of 2 moles of NO2. So there are the less number of moles are on this side. So the reaction will move in backward direction. Got it? Okay, and the same goes with decrease in pressure. So let's discuss why. As you know, PV is equal to nRT. Okay, so at constant temperature, when pressure decreases, volume, when pressure increases, volume decreases. So pressure is inversely proportional to volume. Okay, so see, whenever the pressure will increase the number of moles, the volume will decrease. So let me write it first. So if volume will decrease, this will increase. Okay, so whenever there will be the change in pressure, whenever the pressure is increased, the volume is reduced. So the number of moles per unit volume will increase. So it will look like that the number of moles are increasing, but it is not the case. So equilibrium will try to change it will undo the changes. So it will move in the direction where the number of moles are less. So that is the reason why whenever we are increasing the pressure, the reaction will be moving towards the direction where the number of moles are less. Okay, got it? And same goes with the case when the pressure will be less. If the pressure is less, or I can say that when the pressure is decreased, it will move in the direction where the number of moles are more. So let's move towards the third factor, which is the change in temperature. So let me rub it. So before moving towards the temperature, let's discuss one more thing also. Let's take one. Let me rub it first. Okay. So let's take an example. So let's discuss one more thing. There is one thing called delta mg, which is the number of the difference between the moles in product side minus the number of moles at reactant side. I am talking about the number of moles of gaseous state. Okay, so we will only consider the moles of gases. So delta mg is number of moles on product side minus number of moles on reactant side. If this thing is zero, as in this above direction, so the change of pressure will have no effect. I am reciting it one more, that when delta Ng is zero, the change in pressure will have no effect on the equilibrium. So that is the case. This is the special case. See, the number of moles of N2 and O2 on the total number of moles on the reactant side are 2, and the total number of moles on the product side are also 2. So whenever we will decrease or increase the pressure, the delta Ng is 0. It means the number of moles on the reactant side and on the product side are same. So basically it will have no effect on equilibrium. So now we can move further with the topic of temperature. So see, let's take an example. So here the products are A and B, and see, there is a heat involved in this process. So, and the product is C. So as you can see from this side, from the reactant side, the reaction seems endothermic. Okay, and if you can see from the C side, or we can say from the product side, the reaction seems exothermic. So this is one rule. From that side, from where the reaction seems to be endothermic, the equilibrium will shift towards that side. जिस तरफ से reaction endothermic लगेगी, reaction उसी तरफ forward करेगी. Let's see in this example where there is A and B and delta. So the reaction seems endothermic from this side, so the reaction will move in the forward direction. Or suppose the reaction should have been like this. So in this case the reaction is the temperature is increased. So what will happen is that when the temperature is increased, okay, heat absorbed, so endothermic, so it will move in that direction only. Okay, let me write it, move in that direction. So temperature is increased, so the heat is absorbed. See, from this side you can see C plus delta. Here there is no heat. It means the heat is absorbed in this process. Heat is absorbed in this process. So it will be an endothermic reaction and it will move in this direction. So in this case the equilibrium will shift in the backward direction. So let me rub it. Let's take an example. See, this is the reaction N2 plus 3H2 2NH3 minus 2 kilocalories. So let me rewrite it so that you can understand it with more ease. Okay. See, the reaction is like that N2 plus 3H2 plus 22 kilocalories. So the reaction from this side, from the product side, it seems that the heat is being absorbed. The heat is being absorbed. Temperature increased, heat absorbed. The reaction is endothermic. So it will move in that direction from where it seems endothermic. So the reaction will move forward. So are you clear with this topic? And let's now move with the fourth change, which is the addition of inert materials. So this fourth point, addition of inert materials, let me write it. So this will be our last topic. So inert, what does inert mean? Basically inert means it does not react with reactant and product. So basically it doesn't participate. But what happens when we add inert materials? It increases the volume, okay? So there are two cases. So it is very important to know about these two cases. So one is, let me write it, constant volume, and here one is constant pressure. So at constant volume it will have no effect, and whenever there will be the addition of inert material at constant volume, it will not affect equilibrium. Okay, there will be no effect on any reaction. But when the addition of inert materials take place at constant pressure, there is definitely the change. The reaction will here it is opposite of change in pressure. Whenever there is a change, whenever there is an addition of inert material, the reaction will move in the direction where there the number of moles are more. So let's discuss about this in brief, and why it is happening. We will also discuss why it is happening. Okay. So let me keep it here. Okay. So let's again take our example. So basically, whenever we will add inert material, so what will happen? It will increase the number of, it will increase the volume. So as we have discussed, whenever the volume is increased, one volume. We are talking about constant pressure first. Okay, so whenever the volume is at the constant pressure, the volume increases whenever there is addition of inert material. So whenever volume increases, so the number of moles per unit volume decreases. So it will feel like the number of moles are decreasing, but it is not the case. So as I have said earlier, that equilibrium will try to undo the changes. So it sees that the number of moles are decreasing, so it will move in the direction where there is the concentration of, where the concentration is more. The concentration is more, okay? But as you see, in the case of constant volume, the volume is not decreased, so it will not affect, it will have no effect, zero effect on the reaction. Whether we add inert material or not, it will have no effect on the reaction. So let's conclude it here. So what we have discussed, first of all, what we discussed is why we need Chatelier's principle. Then we discussed what is Chatelier's principle. Then we discussed the factors affecting the Chatelier's principle. So let's recall the factors. First one is concentration, second one is change in pressure, third one is change in temperature, and the fourth one is addition of inert materials. So whenever there will be the increase in concentration of one molecule, the reaction will move in the opposite direction. As we have seen, whenever we were increasing the concentration of reactants, whenever we were increasing the concentration of reactants, the reaction was moving in the forward direction. So to reduce the concentration, it will go, the equilibrium will try to undo the changes. So, and in case of change in pressure, whenever there will be the increase in pressure, the reaction will move where the number of moles are less, and vice versa whenever there will be decrease in pressure. Third one is change in temperature. So as I have told you, from wherever the reaction seems endothermic, the reaction will move in that direction. Okay? And for the last, addition of inert material. So there are two cases: constant volume and constant temperature. So whenever there is a constant volume, see the inert material, what is the property of inert material is that it doesn't react with reactant, neither with product. So basically it just increases the volume, but at constant volume there is no increase in or decrease in volume, so it will have no effect. And second, for the what we can say, in changing at the constant pressure. So at constant pressure, whenever we will add the inert materials, the volume will increase. So what will happen? The volume will increase. So the number of moles per unit volume will decrease. So it seems like the density of moles are decreasing. So it will seem that the number of moles are decreasing, but it is not the case. So equilibrium will try to undo it. So it will try to increase the number of moles. So it will move in that direction where the concentration is more. So thank you. That's all from my side.